In the black waters north of the Arctic Circle, the line between a routine patrol and an international incident is measured in seconds. On February 11, 1992, the Cold War was officially over, yet the silent machinery of nuclear brinkmanship was still running at full power beneath the ice. In this unforgiving darkness, an American submarine was about to prove that treaties signed in Geneva mean nothing when two steel leviathans occupy the same narrow strip of ocean. The date is February 11, 1992. The location is the Barents Sea, 12 nautical miles north of the Russian naval fortress of Severomorsk. The water temperature is 28 degrees Fahrenheit, just below the freezing point of fresh water, kept liquid only by its salinity. At a depth of 150 feet, the USS Baton Rouge moves at 3 knots, a speed so slow that she is barely pushing a wake. Inside the pressure hull, the air is thick with the specific, unmistakable atmosphere of a hunter-killer submarine that has been submerged for 72 consecutive hours. It is a smell compounded of a mine from the carbon dioxide scrubbers, hydraulic fluid, machine oil, and the faint, ozone-tinged scent of high-voltage electrical equipment. But the dominant sensation aboard Baton Rouge tonight is not the smell. It is the cold. The Barents Sea in February is a heat sink of planetary proportions. The steel plating of the hull conducts the Arctic chill directly into the interior spaces. Condensation forms continuously on the metal ribs of the submarine, dripping onto the lagging and the deck plates. The crew wears thermal layers beneath their blue coveralls, their breath sometimes visible in the colder compartments near the hull. This is an environment where human life exists only by the grace of engineering. USS Baton Rouge, hull number SSN 689, is a Los Angeles-class fast-attack submarine. Commissioned in 1977, she is in her 15th year of service, a veteran of the Silent War. She displaces 6,900 tons when submerged and stretches 362 feet from her rounded sonar dome to her tapered stern. Her heart is a single S6G pressurized water reactor, a nuclear furnace that allows her to drive a single shaft at speeds exceeding 30 knots when required. She carries 4 torpedo tubes loaded with Mark 48 ADCAP torpedoes and vertical launch tubes for Tomahawk cruise missiles. She is a predator designed for the open ocean, optimized to hunt Soviet ballistic missile submarines in the deep Atlantic. But tonight, she is not in the deep Atlantic. She is operating on the continental shelf in shallow, cluttered waters, conducting a mission that does not officially exist. The mission is designated Special Operations, a classification that appears in no public record. It generates no written orders beyond the eyes-only directives held by the submarine force commander. The geopolitical context of this mission is chaotic. 3 months earlier, on December 26, 1991, the Soviet Union ceased to exist as a political entity. The hammer and sickle was lowered from the Kremlin flagpole, replaced by the tricolor of the Russian Federation. The Communist Party lost its constitutional monopoly, and 15 republics declared their independence. The ideological confrontation that had defined global politics for 46 years concluded without a nuclear exchange, without an invasion, and without the apocalyptic Third World War that strategists had predicted since 1945. However, in the frozen waters of the Barents Sea, nothing has changed. The political map has been redrawn, but the naval map remains frozen in 1985. The Russian Northern Fleet continues to patrol. Its ballistic missile submarines still carry 500 nuclear warheads aimed at American cities. Its attack submarines still guard the bastion, the protected waters where the strategic reserve hides. The espionage war did not end when the Berlin Wall fell. If anything, it became more dangerous, fueled by uncertainty and the desperate need to know who was actually in control of the nuclear button in Moscow. Commander, name redacted, the captain of Baton Rouge, understands that his vessel is operating in a legal and tactical gray area. The United States claims these waters are international, adhering to the standard 12-mile territorial limit recognized by the law of the Sea Convention. Russia, however, claims a straight baseline measurement that connects headlands rather than following the indentations of the coast. This interpretation extends their territorial claim much further offshore. By American charts, Baton Rouge is conducting a freedom of navigation exercise. By Russian charts, she is an armed intruder violating sovereign territory. If Baton Rouge is detected, the newly formed Russian Federation will protest diplomatically. If she is damaged or forced to surface, the incident will escalate to the highest levels of the White House and the Kremlin, and if she is sunk, 73 crew members will die in water cold enough to stop a human heart in 5 minutes. The approach to the target area requires a level of navigation that borders on art. Global positioning system signals do not penetrate seawater. Deep underwater, a submarine is blind to the satellites orbiting above. The navigators must rely on inertial navigation, a complex system of spinning gyroscopes and sensitive accelerometers that calculate the ship's position by integrating every turn, every acceleration, and every change in velocity from a known starting point. Over days of submerged operations, these systems drift. Errors accumulate. To correct them without surfacing, the crew uses bottom contour mapping, comparing the readings from the fathometer against detailed classified charts of the seabed topography. They are flying blind through a mountain range, using only the echo of the floor to tell them where they are. The environment outside the hull is hostile in every sense. The Barents Sea is cluttered. It is filled with biologics, massive schools of fish, shrimp clouds, and whales that create acoustic noise. It is filled with the mechanical thrum of commercial shipping transiting to and from the port of Murmansk, and it is filled with ice. Pack ice drifts south from the Arctic Circle, creating a ceiling of jagged noise and physical danger. To survive here, Baton Rouge is rigged for ultra-quiet. This is a ship-wide condition of absolute silence. All non-essential equipment is secured. The galley is closed. No pots are banged, no dishes are washed. Crew members off duty remain in their bunks. Those on watch walk in socks or soft-soled shoes. Every valve turn is conducted with deliberate, agonizing slowness to avoid the hydraulic water hammer effect that could ring out like a gunshot. The sonar room is the focal point of the submarine. Located forward of the control room, it is a cramped, dimly lit space dominated by consoles displaying cascading green waterfalls of acoustic data. 3 sonar technicians sit at their stations, wearing sound-powered headsets, their eyes scanning the screens for the faint tonal lines that indicate a man-made object. The BQQ-5D sonar suite is the most advanced passive detection system in the United States Navy. It integrates inputs from a spherical array in the bow, conformal arrays along the hull, and a towed array that can stream miles behind the boat. Tonight, however, the towed array remains retracted. In these shallow, congested waters, a long cable trailing behind the boat is a liability. It reduces maneuverability and can snag on seabed obstructions. Baton Rouge is operating with her hull-mounted ears only. This creates a critical vulnerability. The Los Angeles-class submarine, for all its technological supremacy, has a blind spot. The propeller at the stern generates a cone of turbulence and cavitation noise known as the baffles. This cone extends 60 degrees directly behind the submarine. Any target approaching from within this cone is effectively invisible to the submarine's passive sonar. In the open ocean, a commander clears his baffles by constantly turning, shifting course to let the side arrays listen behind him. But here, 12 miles off the Russian coast, aggressive maneuvering is impossible. The submarine must hold a steady, slow course to avoid detection. The captain accepts the blind spot as the price of the mission. He bets the safety of his ship on the assumption that nothing is behind him. At 2100 hours, the submarine creeps toward its objective. The control room is bathed in red light to preserve the night vision of the periscope operators, though the periscope is currently down. The diving officer of the watch monitors the trim, adjusting water in the ballast tanks to keep the submarine neutrally buoyant. At 3 knots, the dive planes have little effect. The boat is essentially a balloon floating in a fluid, balanced on a knife edge of physics. The target is close. It is not a ship, or a B submarine, or a base. It is a specific coordinate on the ocean floor, a patch of continental shelf where the United States Navy has placed a device of extraordinary sensitivity. The mission is not to destroy, it is to service. Baton Rouge is approaching a wiretap that has been listening to the heartbeat of the Soviet Navy for months. As the digital numbers on the navigation plot tick down, the tension in the control room rises. They are entering the bastion. They are swimming into the lion's den to steal a tooth. The crew knows that every minute they spend here increases the statistical probability of detection. They are relying on the chaos of the Russian transition, the noise of the ocean, and the silence of their own machinery to keep them safe. But the Barents Sea is a crowded place, and unknown to the crew of the Baton Rouge, they are not the only predator prowling the shallow water tonight. As they stabilize their depth and prepare for the most dangerous phase of the operation, the physics of sound and the geometry of blind spots are about to conspire against them. The frozen threshold has been crossed, and there is no turning back. The objective that has brought the USS Baton Rouge into the crosshairs of the Northern Fleet is not a ship, a bunker, or a missile silo. It is a cylinder of titanium and concrete, roughly the size of a coffin, resting in the silt of the Barents Sea floor at a depth of 270 feet. To the untrained eye, it looks like a piece of discarded industrial debris, perhaps a pipe section fallen from an oil rig. But to the Office of Naval Intelligence and the National Security Agency, this cylinder is one of the most valuable assets in the American arsenal. It is an autonomous intelligence collection pod, a wiretap placed on the seabed of the continental shelf. Its location is chosen with surgical precision. It sits directly beneath the transit lanes used by the Soviet, now Russian submarines exiting the naval base at Severomorsk. It is equipped with high-sensitivity hydrophones that do not listen for active pings, but for the subtle, rhythmic mechanical whispers of the enemy fleet. Every submarine has a unique acoustic fingerprint, a voice created by the interplay of its reduction gears, the specific cavitation inception speed of its propeller, the hum of its coolant pumps, and the flow of water over its hull. These signatures are as distinct as a human fingerprint. If the U.S. Navy captures a high-fidelity recording of a specific Russian Akula-class attack submarine, they can load that signature into the fire control computers of every American sub in the Atlantic. The next time that Akula is encountered, the computer will identify it instantly, long before the Russian captain knows he's being watched. The pod is a passive recorder. It stores months of these acoustic fingerprints on reels of magnetic tape protected inside a pressure-proof housing. But the pod has a limitation. It cannot transmit. The data is too dense, and sending a radio signal from the seabed would reveal its location instantly. The only way to get the data is to physically go down and get it. This requirement forces the Baton Rouge into the most dangerous tactical posture a submarine can assume: the hover. Submarines are designed to fly through the water like aircraft fly through the sky. They rely on speed and water flow over their control surfaces, the rudder and dive planes, to maintain depth and heading. When a submarine stops moving, it becomes an unstable balloon. It is subject to the whims of the current, the density of the water layers, and the shifting weight of its own internal systems. At 21:15 hours, the Baton Rouge reaches the coordinates. The captain orders, "All stop." The propeller shaft ceases its rotation. The flow over the hull dies away. The submarine is now drifting. To maintain her depth at exactly 150 feet, suspended 120 feet above the bottom, the crew engages the hovering system. This is a delicate balancing act involving pumps that move seawater between auxiliary tanks to compensate for even a few pounds of weight difference. If they pump too much, the submarine will pop to the surface, exposing the sail to Russian radar. If they pump too little, she will sink to the bottom, potentially crushing the divers or getting stuck in the mud. The ship is now a fixed point in space. She is blind in her baffles. She is silent, but she is also paralyzed. Inside the forward escape trunk, which has been converted into a lockout chamber, the tension is physical. 2 divers are sealed inside. These are not standard crewmen. They are specialists, men whose physiology and psychology have been hardened for an environment that is hostile to human life in every conceivable way. They are wearing heavy vulcanized dry suits, thermal undergarments thick enough for a moonwalk, and full face masks integrated with rebreather systems. Standard scuba gear emits bubbles. Bubbles are noisy, and they rise to the surface, creating a visual wake that can be spotted by patrol aircraft. Rebreathers recycle the diver's breath, scrubbing out the carbon dioxide and adding oxygen, leaving no trail. The divers check their gear. They check the waterproof canisters containing the fresh data tapes and the replacement battery packs. The order is given. The trunk is flooded. The water that rushes in is drawn directly from the Arctic Ocean outside. It is 28 degrees Fahrenheit. Even through the thermal layers, the cold is a shock, a physical blow that tightens the skin and slows the blood. The pressure equalizes. The outer hatch is undogged and swung open. Below them is the abyss. It is pitch black. The sun has not touched this part of the ocean floor for months. The divers switch on their handheld sonar units, high-frequency devices that paint a grainy, green picture of the seabed in their headsets. They push out of the submarine, tethered by safety lines, and descend into the darkness. For the crew remaining aboard the Baton Rouge, this is the white-knuckle phase. For the next 30 to 45 minutes, the submarine is a hostage to the operation. The captain cannot order a speed increase. He cannot turn to clear his blind spot. He cannot react to a threat without first retrieving the men outside or cutting them loose to die. The safety of the ship is entirely dependent on her stealth. They are betting their lives that no one knows they are there. On the seabed, the divers locate the pod. It is crusted with marine growth, a silent sentinel in the muck. They work with practiced efficiency, their movements slowed by the drag of the water and the stiffness of their gloves. They use non-magnetic tools to unscrew the access panel. They pull the cassette of magnetic tape, 6 months of the Northern Fleet's secrets, and insert the fresh blank. They swap the heavy battery packs. They secure the panel. It is a heist conducted in slow motion at the bottom of the world. While the divers work, the sonar operators in the Baton Rouge are straining their ears. The BQQ 5D sonar suite is in passive mode, listening to the ambient noise of the Awa Ocean. They hear the distant churn of a freighter's screw miles away. They hear the crackle of shrimp. They hear the groan of the ice far to the north. At 2140 hours, the divers signal they are returning. They ascend the guideline, a thin nylon thread connecting them to the steel belly of the submarine. They re-enter the lockout chamber. The outer hatch is hauled shut and secured. The pumps engage, draining the seawater back into the ocean. The pressure drops. The inner hatch opens. The divers climb out, shivering uncontrollably, handing over the waterproof canister. The mission is technically a success. The intelligence is secured. The wiretap is reset for another 6 months. But the operation is not over. In fact, the most dangerous moment has just arrived. The Baton Rouge is still stationary. To leave, she must transition from a hovering object back to a moving one. This transition creates noise. The propeller must bite into the water. The water must flow over the hull, creating turbulence. The hydraulic systems for the rudder and planes must wake up. The captain orders the ship to wake up. Rig for dive. Make turns for 3 knots. Course 045. He chooses a northeast heading, moving initially deeper into the Barents Sea to confuse any potential trackers before turning west toward the safety of the Norwegian Sea. The propeller begins to turn. The submarine shudders as it shakes off its inertia. At 2145 hours, the Baton Rouge is accelerating through 4 knots, beginning a slow, banking turn to starboard. The sonar arrays are sweeping the forward sectors. The side arrays are listening to the flanks, but directly behind the submarine, in the 60-degree cone of the baffles, the water is churning. The blind spot is absolute, and in that blind spot, moving on a converging course that geometry and fate have conspired to create, is 9,000 tons of Russian titanium and steel. The Russian submarine B-276 Kostroma is not looking for the Baton Rouge. It doesn't know the Americans are there. It is simply transiting, a massive predator moving through its own backyard. But the physics of the ocean are unforgiving. 2 silent hunters are moving through the same dark room. One is turning, the other is rising, and neither one can see the other. The silence of the Barents Sea is about to be shattered by the shrieking of tearing metal. The mission to steal the secrets of the fleet has succeeded, but the price is about to be paid in a collision that will rock the foundations of the post-Cold War world. While the divers of the USS Baton Rouge were drying off in the lockout chamber, shivering from the thermal shock of the Arctic Ocean, a shadow was moving through the deep water 8 nautical miles to the southeast. It was not a school of fish or a drifting iceberg. It was a machine designed for the specific purpose of hunting and destroying American submarines. The vessel was the B-276 Kostroma. To the NATO intelligence analysts who tracked her, she was a Sierra-class attack submarine. To the Russian crews who sailed her, she was Project 945, the Barracuda. Commissioned in 1987, she was one of the most advanced and expensive fighting ships ever built by the Soviet Union. If the Baton Rouge was a shark, sleek, fast, and aggressive, the Kostroma was an ironclad leviathan. Her defining characteristic was not her speed, though she was capable of 32 knots submerged. It was her skin. Unlike the Baton Rouge, which was constructed from high-yield HY-80 steel, the Kostroma was built entirely from titanium alloy. Titanium is lightweight, non-magnetic, and incredibly strong. It allows the submarine to dive to depths exceeding 2,000 feet, far below the crushed depth of American torpedoes or the Baton Rouge herself. It also makes the hull remarkably resistant to magnetic detection, rendering the submarine invisible to the magnetic anomaly detectors used by NATO patrol aircraft. But titanium is difficult to weld and astronomically expensive to refine. The cost of building a single Sierra-class boat was so high that Western analysts often referred to them as the goldfish. On the night of February 11th, the Kostroma was not hunting. She was conducting a routine transit. Having departed the piers at Severomorsk, she was proceeding northwest toward her assigned patrol sector in the Norwegian Sea. Her captain was not expecting trouble. He was operating in what he considered his own backyard, the sovereign territorial waters of the Russian Federation. He believed the area was sanitized, protected by the formidable surface and air assets of the Northern Fleet. The Kostroma was cruising at a depth of roughly 200 feet, slightly below the Baton Rouge. Her course was steady. Her sonar systems were active but degraded. The same acoustic clutter that allowed the Americans to hide. The shrimp noise, the ice grinding, the shipping traffic also blinded the Russians. The geometry of the impending disaster was drawn by the laws of physics. Both submarines were operating in a co-located space, yet neither knew the other existed. This blindness was not due to incompetence, it was due to the inherent limitations of underwater warfare. Passive sonar, the primary ears of a submarine, works by listening for sound radiating from a target. But a submarine's own movement creates a problem. The rotation of the propeller, the flow of water over the rudder, and the hum of the engine room machinery create a cone of noise directly behind the boat. This is the baffles, a 60-degree blind spot extending outward from the stern. A submarine cannot hear what is directly behind it. To check this blind spot, a captain must perform a crazy Ivan or a baffle clear, a sharp turn that allows the side-mounted sonar arrays to listen to the water previously obscured by the propeller. But tonight, neither submarine was clearing its baffles. The Baton Rouge had been hovering, stationary and silent for nearly an hour. She had just begun to move, accelerating slowly on a northeast heading. Because she was moving away from the Kostroma, her propeller was pointing directly at the approaching Russian boat. The noise of her own wake was masking the sound of the Kostroma approaching from behind. Conversely, the Kostroma was approaching the Baton Rouge from the Americans' starboard quarter, deep in the blind spot. The Russian sonar operators heard nothing because the American boat was in ultra-quiet mode, her machinery silenced, her screw turning so slowly it barely disturbed the water. To the Kostroma, the ocean ahead appeared empty. The acoustic environment of the Barents Sea acted as the final accomplice. Sound in the ocean does not travel in a straight line. It bends. It is refracted by temperature layers, salinity gradients, and pressure. On this night, the thermal layers were mixing poorly. Sound waves were being trapped in channels or deflected into the seabed. A submarine could be a mile away and sound like it was 10 miles away, or it could be completely inaudible until it was right on top of you. At 2150 hours, the gap between the two vessels closed to less than a mile. In the open ocean, this is considered knife fight range. In the shallow, murky water of the continental shelf, it is practically a collision course. The Baton Rouge continued her slow turn, swinging her bow toward the open sea. Her sonar operators were focused on the forward sectors, scanning for the patrol boats they knew were operating near the coast. They saw nothing on the screens but the green fuzz of biological noise. They were confident. The hard part was over. The divers were back inside. The data was secure. They were slipping away into the night. Aboard the Kostroma, the mood was equally routine. The captain checked his watch. It was time for a scheduled communications window. Russian submarine doctrine differed significantly from American procedures. While U.S. boats relied on trailing wire antennas to receive signals while deep, Russian boats frequently came to periscope depth or surface to burst transmit data to the fleet headquarters. The Kostroma needed to talk to Severomorsk. To do that, she needed to go up. The Russian captain ordered preparations for surfacing. This was not a slow, gentle rise to periscope depth. Russian naval doctrine emphasized speed and aggression. A slow submarine at shallow depth is vulnerable to aircraft. The standard procedure was to minimize the time spent in the danger zone. The Kostroma would not creep to the surface. She would punch through it. In the control room of the Kostroma, the order was given to prepare for an emergency blow. This is a misnomer in this context. It wasn't an emergency, but the procedure uses the emergency systems. High-pressure air banks were primed. Vents were checked. The plan was to blast compressed air into the ballast tanks, displacing tons of seawater in seconds, making the submarine positively buoyant like a cork held underwater, and then released. At 21:55 hours, the two trajectories intersected. The Baton Rouge was at 150 feet, moving horizontally at roughly 4 knots. The Kostroma was at 200 feet, directly below and slightly behind the American boat, preparing to move vertically. The separation distance was now measured in yards. The acoustic energy of the Kostroma's engines should have been detectable by the Americans, but the Baton Rouge was in the middle of a turn. The flow of water across her own hull was creating a wash of own-ship noise that cluttered the passive arrays. The sonar sphere in the bow was pointing away from the threat. The towed array was retracted. The flank arrays were blinded by the turn. It was the perfect acoustic storm. The American boat was deaf to the rear. The Russian boat was deaf to the front because of the noise of its own preparations for surfacing. The crews of both vessels went about their duties, separated by a few hundred yards of freezing water and a wall of silence. On the Baton Rouge, the navigator was plotting the course to the Norwegian frontier. On the Kostroma, the ballast control officer gripped the levers that would release the high-pressure air. There was no warning. There was no ping of active sonar to alert the Americans that they had been painted. There was no frantic call of torpedo in the water. There was only the hum of the ventilation fans and the quiet routine of the watch standing. In the physics of submarine warfare, stealth is the primary defense. But stealth works both ways. When you hide perfectly, you also blind yourself to the things that are hiding near you. The Baton Rouge had achieved perfect invisibility, and in doing so, she had become a ghost to herself. She occupied a point in space that the Kostroma believed was empty. At 2200 hours, the Russian captain gave the command. "Blow all main ballast." The valves opened. The roar of a high-pressure air rushing into the Kostroma's tanks was deafening, a sound like a jet engine igniting underwater. It instantly masked all other sounds in the ocean. Even if the Baton Rouge had heard it at that exact second, it was too late. The physics of buoyancy took over. The Kostroma, all 9,000 tons of titanium and nuclear machinery, began to rise. She accelerated upward, her bow pitching up, driving toward the surface with the unstoppable momentum of a freight train. She wasn't just rising, she was ascending into the exact space occupied by the hull of the USS Baton Rouge. The silent convergence was over. The collision was now a mathematical certainty. In the fraction of a second that followed the opening of the Kostroma's ballast valves, the physics of the Barents Sea underwent a violent inversion, the Russian submarine, shedding tons of water weight and replacing it with buoyant air, transformed from a silent, drifting predator into a ballistic missile aimed at the surface. She was rising at a steep angle, her bow pitched up, her titanium sail cutting through the water column with unstoppable kinetic energy. Directly in her path, the USS Baton Rouge was plodding along at 4 knots, oblivious to the mountain rising from the deep to meet her. The collision occurred at 2016 hours local time. It did not sound like an explosion. There was no boom, no concussion wave typical of a torpedo detonation. Instead, it was a sound that every submariner fears in their nightmares. A shrieking, grinding tear that seemed to scream from the very bones of the ship. It was the sound of My-80 steel, one of the toughest alloys known to man, being gouged open by titanium. The impact point was along the Baton Rouge's port side, just aft of the sail. The Kostroma's massive sail, reinforced to punch through Arctic ice pack, acted as a serrated knife. It slammed into the American hull with the force of a freight train derailment. Inside the Baton Rouge, the world tilted violently. The 6,900-ton submarine was shoved upward and rolled hard to starboard by the ascending mass of the Russian boat. In the control room, the sudden lurch threw the officer of the deck against the periscope stand. Coffee cups, logbooks, and loose equipment went flying. The diving officer of the watch grabbed the ballast control panel to steady himself, his eyes locked on the inclinometer, which was swinging wildly past 10 degrees. "Collision! Collision port side!" The shout from the sonar supervisor was redundant. The entire crew felt it. The vibration was so intense it rattled teeth. It was a shudder that traveled the length of the keel, a resonant frequency of disaster that told the seasoned chiefs instantly that the pressure hull had been struck. For a terrifying heartbeat, no one knew what had hit them. Was it a mine, a torpedo that failed to detonate, a seabed obstruction? "Sound the collision alarm." The captain's voice cut through the chaos, calm and disciplined. The electronic klaxon began its rhythmic, pulsing wail. "Grr, ah-oo, grr." a sound that triggers an adrenaline response drilled into sailors since boot camp. Damage control reports began to flood in over the sound-powered phones. The news was grim. The impact had not breached the reactor compartment. The nuclear heart of the ship was secure, but it had devastated the submarine's buoyancy control. The Kostroma's sail had ripped 2 massive gashes into the Baton Rouge's port-side ballast tanks. These tanks are the lungs of the submarine. They hold the air that keeps the boat on the surface, or the water that allows it to dive. Now they were ruptured. The high-pressure air that was supposed to act as a safety reserve vented violently into the ocean with a deafening roar. Seawater rushed in to replace it. The Baton Rouge lost buoyancy on her port side instantly, causing the list to worsen. The submarine was now fighting 2 warring forces. The impact had pushed her up, but the flooding was trying to drag her down. The captain ordered an emergency blow of the remaining healthy tanks. "Blow all main ballast! Rise, rise!" High-pressure air screamed into the starboard and forward tanks. The submarine shuddered, fighting the drag of the damaged hull sections. The depth gauge needle spun backward. 150 feet, 100 feet, 50 feet. They were rocketing toward the surface, out of control. Beneath them, the Kostroma was suffering her own catastrophe. The impact had crushed the leading edge of her sail, smashing the sonar sensors housed there and denting the heavy titanium plating. The Russian crew, thrown from their feet, believed they had struck an iceberg or perhaps a surface ship that had drifted into their patrol zone. They continued their ascent, driven by the momentum of their own emergency blow. At 2017 hours, the surface of the Barents Sea erupted. The Kostroma breached first, her black sail breaking the waves in a spray of white foam. Seconds later, 70 yards ahead, the USS Baton Rouge broached, rolling heavily in the swell, her hull groaning as the structural stress redistributed. The silence that followed the surfacing was absolute. The grinding noise stopped. The alarms were silenced to allow voice communications. The captain of the Baton Rouge ordered the bridge manned. He climbed the ladder to the sail, undogged the hatch, and pushed it open. The Arctic air hit him like a physical blow, 28 degrees below freezing with the wind chill. He raised his binoculars and looked astern. There, emerging from the darkness like a sea monster, was the silhouette of a Russian Sierra-class submarine. She was massive, her hull sleek and low in the water. Smoke or steam was venting from her sail, likely damaged hydraulic lines. She was less than a football field away. The realization was a punch to the gut. They hadn't hit a rock. They hadn't hit a mine. They had collided with one of the most advanced attack submarines in the Russian Navy, right in its own front yard. "Bridge, control, we have a visual on a Russian Sierra-class, surfaced, bearing 180 relative." The captain called down, his voice flat. "Rig the ship for surface transit. Get me a damage assessment on the pressure hull immediately." The situation was a nightmare scenario. The Baton Rouge was floating, but she was crippled. The list to port was noticeable, about 8 degrees. The ballast tanks on that side were shredded metal. If they tried to dive now, the air would bubble out, the water would rush in, and the submarine would sink straight to the bottom like a stone. They had lost the ability to hide. Across the water, on the bridge of the Kostroma, Russian lookouts were scrambling out. They trained their searchlights on the American vessel. The beams swept across the water and illuminated the hull number and the distinctive profile of the Los Angeles class. For a few tense minutes, the 2 captains stared at each other across the black water. It was a standoff at point-blank range. The Kostroma had torpedo tubes. The Baton Rouge had torpedo tubes. In the confusion of the moment, with adrenaline pumping and hulls damaged, the instinct to fight was primal. If the Russian captain believed the collision was a deliberate ramming attack, an act of war, he might order a snapshot. But there was no fire. The Russian searchlight lingered on the Baton Rouge's damaged flank, documenting the gash, and then clicked off. The Kostroma turned away slightly, wallowing in the swell, assessing her own wounds. She was hurt, but her titanium hull had won the physical contest. She was watertight. The Baton Rouge was not. Inside the American boat, the engineering team reported back. The news was mixed. The reactor was stable. The propulsion shaft was turning freely. They hadn't bent the screw. But the pressure hull, the steel tube that keeps the ocean out and the crew alive, had suffered stress fractures. The collision had rung the boat like a bell, and the welds near the impact site showed signs of micro-cracking. Captain, Engineering, we have structural integrity for surface transit, but I do not recommend submerging. We have lost integrity in the port ballast complex, and the pressure hull is suspect. We are a surface ship now, sir. The captain acknowledged. He knew what this meant. They were 12 miles off the coast of Russia. They were visible to radar. They were visible to satellites. They were leaking oil and hydraulic fluid into the pristine Arctic waters. And they had to get home. Navigator, give me a course for international waters. Best speed 12 knots. Do not strain the hull. As the Baton Rouge began to limp northward, trying to put distance between herself and the crime scene, the reality of their position set in. They were alone. They were damaged, and they were about to become the center of a diplomatic hurricane. The collision was over, but the ordeal of survival had just begun. The ocean, usually their sanctuary, had become a hostile plain of ice and wind, and they had nowhere to hide. The moment the hatch of the USS Baton Rouge cracked open to the Arctic air, the fundamental nature of the vessel changed. For 15 years, she had been a creature of the deep, a machine designed to operate in a world of silence, pressure, and invisibility. Now, battered and listing 8 degrees to port, she was reduced to the status of a surface ship, a low, clumsy target wallowing in the freezing swells of the Barents Sea. The submarine was now completely exposed. The cloak of invisibility, the single greatest asset of the submarine service, had been stripped away. To the radar operators at the Severomorsk Naval Base, just 12 miles south, the Baton Rouge was no longer a ghost or a suspected contact. She was a solid, undeniable blip on the screen, moving at a pitiable 12 knots. The captain stood on the bridge, the icy wind tearing at his parka. The situation was precarious in a way that tactical manuals could not fully address. They were sitting inside the bastion, the sacred defensive zone of the Russian Northern Fleet. Technically, by American charts, they were on the very edge of international waters, but by Russian charts, they were inside the sovereign territory of the Russian Federation. In the confusion of the post-Soviet era, no one knew which rules of engagement applied. Would a Russian frigate fire a warning shot? Would they attempt to board? Communications became the lifeline. With the submarine surfaced, the radio room established a high-priority satellite uplink. The message went out with flash precedence, the highest priority in the U.S. military communications network, reserved for contact with the enemy or the outbreak of war. USS Baton Rouge collided with submerged contact, surfaced, no casualties, reactor secure, hull integrity compromised. Request guidance. The message hit the desk of the commander, Submarine Force Atlantic, comms Sublint, in Norfolk, Virginia, like a thunderclap. Within the hour, the information had raced up the chain of command, to the Chief of Naval Operations, to the Secretary of Defense Dick Cheney, and finally to the Oval Office. President George H.W. Bush was facing a diplomatic nightmare. The Soviet Union had dissolved only weeks earlier. The relationship with the new Russian president, Boris Yeltsin, was fragile. The West was trying to prop up the Russian economy to prevent nuclear chaos. Now, an American spy submarine had just rammed one of Russia's newest attack boats in its own front yard. It looked like an act of aggression, or at the very least, a humiliating reminder that the U.S. Navy was still prowling the wreckage of the Soviet Empire. In Moscow, the reaction was a mixture of outrage and confusion. The Russian Navy was in disarray, with officers going unpaid and ships rusting at the piers, but the instinct to defend the motherland remained intact. The collision was seen as a provocation, The Russian Foreign Ministry drafted furious protests, accusing the United States of gangsterism and violating the innocent passage laws of the sea. Back on the bridge of the Baton Rouge, the geopolitics were abstract. The danger was physical. The weather was deteriorating. The Barents Sea is unforgiving in February. The wind picked up, driving snow horizontally across the deck. The swells rose to 15 feet. A surfaced submarine is a terrible sea boat. It has no keel to stabilize it. It rolls drunkenly in the waves, snapping back and forth with a violence that sickens even veteran sailors. For the Baton Rouge, this motion was terrifying for another reason. The engineering team was monitoring the stress fractures in the pressure hull. Every time the boat slammed into a trough, the steel groaned. The fear was that the micro cracks near the collision site would propagate, that the hull would unzip like a tear in fabric, leading to catastrophic structural failure. Then came the Russians. At 0200 hours, the radar detector in the bridge bristled with activity. An aircraft was approaching from the south, flying low and fast. It was an Ilyushin Il-38 May, the Russian equivalent of the P-3 Orion, a maritime patrol aircraft laden with sensors and depth charges. The plane roared overhead at mast-top height, its 4 turboprop engines screaming. It banked hard, circling the wounded submarine. Then the bay doors opened. The lookouts on the bridge flinched, expecting weapons. Instead, the sky turned blinding white. The Il-38 dropped a string of magnesium parachute flares. They hung in the air, burning with the intensity of small suns, casting a harsh, flickering light over the black water. The Baton Rouge was illuminated. The Russians were taking pictures. They were documenting the list, the damage, the location. It was a message sent in light. We see you. You are in our house, and you are helpless. The plane circled for 20 minutes, dropping more flares, buzzing the submarine repeatedly. It was a psychological hammering. The crew below decks could hear the drone of the engines through the hull. They knew that if the pilot flipped a switch, he could drop a torpedo that would break the submarine's back. They had no air defense. They had no way to shoot back. They could only endure the scrutiny and keep steaming north. The captain maintained his course. He ordered the signalmen to flash the ship's identification code light, asserting their status as a U.S. Navy vessel exercising right of innocent passage. It was a legal fiction, a thin shield of international law held up against a maritime patrol bomber. Eventually, the Il-38 turned back toward the coast, low on fuel. But it was replaced by a destroyer on the horizon, shadowing them, keeping pace at a distance of 5 miles. The Russian Navy was escorting them out, ensuring they left the bastion. The transit to safety was a slow, grinding ordeal. The Baton Rouge could not dive to escape the weather. She had to smash through it. For 5 days, the submarine limped westward, rounding the North Cape of Norway. The crew lived in a state of suspended anxiety. The list to port made walking down the passageways difficult. Sleeping in the bunks required wedging oneself in with life jackets to keep from rolling out. The engineering watchstanders checked the bilges constantly, looking for new leaks. The reactor was kept at low power, just enough to turn the screw and keep the lights on. They were nursing the ship home. The diplomatic cables continued to fly between Washington and Moscow. The U.S. government officially denied any wrongdoing, issuing a curt statement that the Baton Rouge was conducting routine operations in international waters. The Russians countered with charts showing the collision point clearly within their territorial claim. It was a stalemate of words, but behind closed doors, assurances were made. The spy flights would be dialed back. The in-your-face operations would be paused. The collision had frightened both sides into a moment of caution. On February 16th, 4 days after the collision, the coastline of Norway appeared on the radar. It was the coast of a NATO ally. The Baton Rouge was finally out of the Russian kill box. She entered a secluded fjord near Tromsø, where a NATO support facility offered secure mooring. As the lines were thrown across to the pier, the adrenaline finally began to fade, replaced by a profound exhaustion. They had survived the collision, they had survived the ascent, they had survived the Russian response in the Arctic storm, but as the Norwegian engineers and U.S. Navy repair teams came aboard to inspect the damage, the reality of the situation shifted from survival to assessment. The Baton Rouge looked like a prize fighter who had gone 12 rounds. Her port side was a mess of torn, sound-dampening tiles and scraped steel. The ballast tanks were visibly gashed, but it was the internal assessment that would seal her fate. Detailed ultrasonic scans of the pressure hull revealed the truth that the naked eye missed. The steel was traumatized. The shock of the impact had done more than dent the metal. It had changed its crystalline structure in localized areas. The circle of strength, the perfect geometry required to withstand the crushing pressure of the deep ocean, was compromised. The captain and the crew realized that their boat was broken. She might float and she might steam, but she could no longer be a submarine. She could never again dive to test depth. She could never again hide in the deep, crushing silence. She was a surface ship now, permanently tethered to the atmosphere. Temporary repairs were made, patches welded over the gashes to make the hull hydrodynamic enough for an Atlantic crossing. But the mood was somber. The Baton Rouge was leaving the front lines for the last time. She was beginning the long, slow voyage back to the United States, not as a conquering hero, but as a casualty of a war that was supposed to be over. Behind them, in the shipyards of Severomorsk, the Kostroma was also being assessed. Her sail was dented, her sonar shattered. But her titanium hull, the pride of Soviet engineering, had held. She would be repaired, she would sail again, and in a final act of naval defiance, her crew would paint a small red star with the number 1 on her sail, a kill mark. They claimed the victory. And looking at the battered, listing form of the Baton Rouge slipping out of the fjord, it was hard to argue they were wrong. The transit from Norway to the United States was a 12-day funeral procession for a machine that was still breathing. On March 1st, 1992, the USS Baton Rouge cast off her lines in Tromsø and turned her bow west, facing the gray, heaving expanse of the North Atlantic. She was heading home, but she was doing it in the most humiliating way possible for a submarine. On the surface, at 12 knots, exposed to the sky and the sea. A Los Angeles-class submarine is a marvel of hydrodynamics when submerged. It slips through the water with the grace of a predatory fish. But on the surface, it is a clumsy, cylindrical log. It has no keel to stabilize it against the roll of the waves. In the rough winter seas of the Atlantic, the Baton Rouge did not cut through the water. She wallowed in it. She rolled 20 degrees to port, then 20 degrees to starboard, a sickening, relentless pendulum motion that made even the most seasoned sailors retch. For the crew, the voyage was a physical and psychological ordeal. The boat was rigged for reduced status. The reactor was kept at minimal power, just enough to turn the shaft. The combat systems were largely secured. The mood in the mess decks was somber. There is a specific bond between a submariner and his boat, a trust that the steel tube will protect him from the crushing pressure of the deep. That trust had been fractured. Every time the hull slammed into a trough, sending a shudder through the deck plates, men looked at the bulkheads, wondering if the microscopic cracks the engineers had found in Norway were growing. Was the hull unzipping? Was the steel fatigue propagating? They were sleeping inside a pressurized can that had been dented by a sledgehammer, tossing around in one of the roughest oceans on Earth. Navigation was a chore. Because they were restricted to the surface, they had to obey the rules of the road for surface ships. They had to run navigation lights. They were visible to radar. Commercial airliners flying overhead could look down and see the long, black shape cutting a white wake in the gray water. For a crew trained to be invisible, to be the hole in the water, this visibility felt like nakedness. On March 13, 1992, the Baton Rouge passed Montauk Point and entered Long Island Sound. She steamed up the Thames River toward Naval Submarine Base New London in Groton, Connecticut. It was a homecoming, but there were no bands playing on the pier. There were no banners welcoming the heroes of the Barents Sea. The arrival was handled with quiet, administrative efficiency. The submarine was tied up, the brow was thrown over, and the crew was debarked. Almost immediately, the ship became the property of the engineers. The Baton Rouge was moved into a graving dock, a massive concrete chamber that can be sealed off from the river and pumped dry. As the water level dropped, the full extent of the damage was revealed to the naked eye for the first time. It didn't look like a catastrophe. There were no gaping holes into the people tank. The pressure hull wasn't crushed like a soda can. Instead, there were long, ugly scrapes along the port side, areas where the special sound-dampening anechoic tiles had been stripped away to reveal the bare steel beneath. There were dents in the ballast tanks, cuts in the fiberglass superstructure. To a civilian, it might have looked like a minor fender bender. But the naval architects from Electric Boat and the structural experts from Naval Naval Sea Systems Command, weren't looking at the paint. They were looking at the crystallography of the steel. They deployed ultrasonic scanners and X-ray equipment to peer inside the metal itself. What they found was a death sentence. The collision had subjected the Baton Rouge to a massive impulse load. When 9,000 tons of Russian submarine struck her, the energy didn't just dent the side, it traveled through the circular ribs of the hull. The steel of a submarine is HY80, a high-yield alloy designed to flex under pressure, but it has limits. The impact had shocked the steel beyond its elastic limit in critical areas. The assessment report was dry, technical, and devastating. The pressure hull had suffered localized deformation and stress concentrations. In plain English, the circle was no longer a perfect circle. If the Baton Rouge were to dive to her test depth, dangers deep, the immense pressure of the ocean would seek out these imperfections. The hull wouldn't flex. It would buckle, and once it buckled, it would implode instantly. The engineers presented the Navy with a choice. The boat could be fixed. It was physically possible. They could cut out the damaged sections of the pressure hull, huge rings of steel, and weld in new ones. They could rebuild the ballast tanks. They could recertify every inch of the boat. But then came the second set of numbers. The cost. The repair estimate was approximately $80 million. But there was a catch. The Baton Rouge was due for a reactor refueling in 1995, a scheduled maintenance period that would cost another $200 million. To keep her in service, the Navy would have to spend nearly $300 million on a single submarine. In 1985, at the height of the Cold War, the Navy would have written the check without hesitation. But this was 1992. The Soviet Union was gone. The peace dividend was the new political slogan. The defense budget was being slashed. The Navy was already building the new, ultra-advanced Seawolf class and designing the future Virginia class. The Baton Rouge was hull number 689. She was a Flight I Los Angeles class, the oldest version of the boat. She lacked the vertical launch tubes for cruise missiles that the newer boats had. She was quieter than the Russians, but louder than the new improved Los Angeles boats. The actuaries in the Pentagon ran the equation. Was it worth spending $300 million to save a 15-year-old submarine that was already becoming obsolete? The answer was a cold, bureaucratic no. The term used was constructive total loss. It meant that while the ship wasn't destroyed, the cost of fixing it exceeded its value to the Navy. The collision hadn't sunk the Baton Rouge in the Barents Sea, but it had sunk her in the budget meetings of Washington, D.C. The contrast with the Kostroma was bitter. The Russian submarine had limped back to Severomorsk with a crushed sail and shattered sonar, but her pressure hull, made of titanium, had survived. Titanium is harder to work with than steel, but it has a higher strength-to-weight ratio, and, crucially, it is more elastic. It had absorbed the blow and sprung back. The Russian Navy, desperate to maintain its strength amidst the collapse of its country, simply hammered out the dents, patched the sail, and sent the Kostroma back to sea. They couldn't afford to build new ships, so they kept the old ones running. The U.S. Navy, wealthy enough to be choosy, decided the Baton Rouge was trash. In late 1993, the official order came down. USS Baton Rouge was to be inactivated. The crew was slowly broken up. Sailors received orders to transfer to other boats, the USS Miami, the USS Philadelphia, the USS Dallas. They packed their sea bags and left. The nuclear fuel was removed from the reactor, the heart of the ship surgically extracted. The missile tubes were filled with concrete. The classified electronics were stripped from the consoles. The periscopes were pulled. The submarine that had prowled the top of the world, that had tracked Soviet boomers through the Denmark Strait, that had stolen the secrets of the Northern Fleet, was now just a hollow steel carcass rusting in the brackish water of the Thames River. The long limp home had ended not in a repair bay, but in a scrapyard queue. The Baton Rouge had fought the Cold War and survived, only to be killed by a 2-second accident and a spreadsheet. She was the first casualty of the peace, a warrior retired not because she couldn't fight, but because she was no longer worth the cost of the armor she wore. On January 13, 1995, the flag of the USS Baton Rouge was lowered for the final time at the Mare Island Naval Shipyard in California. The ceremony was conducted with the rigid dignity of naval tradition. The crew, standing in their dress blues, listened to the orders being read, the whistle blown, and the watch secured. But beneath the pageantry lay a bitter reality. A warship designed to serve for 30 years was being put to death at the age of 18. The Baton Rouge had survived the Barents Sea, but she could not survive the accounting department. The cost of repairing her crushed pressure hull was simply too high for a navy that was downsizing in the afterglow of the Cold War victory. She became the first Los Angeles-class submarine to be decommissioned, a distinction no crew ever wants to claim. The process of her destruction was methodical and absolute. She was towed north to the Puget Sound Naval Shipyard in Bremerton, Washington, to enter the ship's submarine recycling program. This is the graveyard of the American nuclear fleet, a place where the machines that once held the power to destroy civilizations are reduced to scrap metal and hazardous waste. Workers armed with plasma torches descended on the hull. The steel that had protected the crew from the crushing depths of the Atlantic and the freezing waters of the Arctic was sliced apart section by section. The missile tubes were cut out. The sonar sphere was removed. The high-yield HY-80 steel, valuable for its purity, was melted down to be reborn as razor blades, girders, or perhaps the fenders of civilian cars. The only part of the Baton Rouge that remains intact is her heart. The reactor compartment, a 1,000-ton cylinder of lead and steel containing the defueled nuclear core, was cut free from the rest of the ship. It was welded shut, painted white, and barged up the Columbia River to the Hanford site in eastern Washington. There, it was dragged into a massive, open trench in the high desert, joining the reactor compartments of dozens of other submarines. If you look at satellite imagery of Hanford today, you can see them, rows of white cylinders arranged in neat lines, slowly being buried by the shifting sands. They are the tombstones of the silent service, monuments to the machines that won the Cold War without firing a shot. Thousands of miles away, in the freezing harbor of Severomorsk, the story had a different ending. The Russian submarine B-276 Kostroma did not go to the scrapyard. The Russian Federation, cash-strapped and desperate to maintain its status as a great power, could not afford to throw away a titanium submarine. Her crew and the shipyard workers at Rickover hammered out the dents in her sail. They replaced the sonar arrays. They patched the outer hull. And then they did something that spoke volumes about the Russian mindset. On the side of the Kostroma's black sail, just below the bridge, the crew painted a small red star with the number 1 inside it. In Aya naval tradition, a kill mark is reserved for sinking an enemy ship in combat. Technically, the Baton Rouge had not sunk, Technically, the two nations were at peace, but to the sailors of the Northern Fleet, the distinction was irrelevant. They had collided with an American spy boat. They had survived. The American boat had been scrapped. In the brutal logic of the sea, that was a kill. The Kostroma returned to active service. She continued to patrol the Barents and Norwegian seas for another 20 years, a scarred veteran of a war that never officially happened. She was finally decommissioned in 2014, outliving her American adversary by nearly 2 decades. The kill mark remained on her sail until the very end, a source of pride for her crew and a source of quiet irritation for American naval intelligence officers who saw it in periscope photographs. The collision of February 1992 was not an isolated freak accident. It was the violent culmination of a dangerous game of blind man's bluff that had been played beneath the waves for 40 years. It joined a secret list of underwater smash-ups, the USS Tautog colliding with the Soviet Black Lila in 1970, the USS Grayling hitting a Russian Delta-class boomer in 1993. These incidents revealed the terrifying truth of submarine warfare. Despite billions of dollars spent on sonar, despite the genius of the engineers and the training of the crews, the ocean remains fundamentally opaque. When two silent hunters operate in the same dark room, eventually they will bump into each other. The margin between an intelligence-gathering mission and a catastrophic hull breach is often just a few feet of water and a few seconds of bad luck. The mission of the Baton Rouge, the wiretap in the freezer, did not end with her death. The intelligence war didn't stop just because the Soviet Union fell. The need to know what the Russians were doing, where their missiles were aimed, and how their new submarines sounded was too critical. Other boats picked up the burden. The USS Pash, the most decorated ship in U.S. naval history, continued the dangerous work of seabed operations. Later, the USS Jimmy Carter, a modified Seawolf-class submarine, was built specifically to tap undersea fiber optic cables and retrieve foreign technology. The bastion north of Severomorsk is still patrolled today. The cat-and-mouse game continues, evolved with better sensors and quieter drives, but played on the same lethal board. For the men of the Baton Rouge, the legacy is personal. They are the survivors of a ghost ship. They walk through civilian life carrying the memory of that night, the grinding scream of the impact, the sickening lurch of the deck, the cold terror of the ascent. They remember the sound of the Russian flares sizzling in the water and the long, rolling transit home. They received no medals for the collision. There were no parades. In the eyes of the Navy, losing a hull is a failure, regardless of the circumstances. But among the brotherhood of submariners, there is a quiet respect. They went into the enemy's backyard. They did the job, and when the worst happened, they brought the boat and every soul aboard home, safely. In the end, the story of the Baton Rouge is a reminder of the price of vigilance. The Cold War is often remembered as a war of ideologies, of speeches and treaties. But it was fought by machines and the men inside them. It was fought in the crushing dark, in water freezing enough to kill, where the only thing separating life from death was the integrity of a weld and the skill of a 19-year-old sonar man. The Baton Rouge is gone, cut into razor blades and buried in the desert. The Kostroma is gone, rusted away at a Russian pier, but the silence they operated in remains. The Barents Sea is still deep, still dark, and still hiding the secrets of nations who do not trust one another. The game goes on. Only the players change. The story of the USS Baton Rouge serves as a stark reminder that history does not always end with a treaty. We tend to view 1991 and 1992 as the years when the world breathed a sigh of relief, believing the danger had passed. But beneath the waves, the tension never truly broke. The machines of war kept running, kept listening, and kept colliding in the dark. There is something haunting about the fate of the Baton Rouge. She was a predator of the deep, a pinnacle of American engineering, yet she was undone not by a torpedo, but by the chaotic, messy reality of a world in transition. She reminds us that the line between peace and war is often thinner than the steel hull of a submarine. The men who served on her, and the men who serve on her successors today, live in a world the rest of us are not allowed to see. They carry the weight of our security in silence, operating in an environment where a single mistake can have geopolitical consequences. They are the invisible sentinels, holding the line in the freezing dark so that we can live in the light. Thank you for spending part of your day with us to explore this hidden chapter of the Silent Service. If this journey into the depths of the Cold War's aftermath meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.